Hi everyone. Today we are going to discuss about numeric literals in Java. This presentation will cover the concept of numeric literals and their types, usages, and their practical demonstration using IntelliJ IDEA. Let's begin. In Java, literals are constant values that are directly written into the program. Numeric literals are specifically numbers that represent fixed values in the code. They are very useful for defining constants without needing variables. For example, when we write int x equal to 10, here 10 is a numeric literal. Next one is the types of numeric literals. Java supports different types of numeric literals. Decimal literal, which are base 10 numbers for each int x equal to 25. Binary literals introduced in Java 7, written with the prefix 0b, such as int y equal to 0b 1010, which equals 10. Octal literals, written with a leading 0, like int z equal to 027, which equals 23 in decimal. Hexadecimal literals, written with prefix 0x, such as int h equal to 0x1a, which equals 26 in decimal. This flexibility is very useful when working with different number systems. Next one is the floating point literals. In addition to integers, Java also supports floating point literals. These are used when we need decimal values. The most common example is written sometimes like double pi equal to 3.14159. We can also use scientific notation. For example, double num equal to 1.2e3, which means 1.2 multiplied by 10 to the power of 3 or 1200.0. The next one is the underscores in numeric literals. To make large numbers more readable, Java allows underscores in numeric literals. For example, instead of writing 10 lakh, we can write 1 underscore 30 underscore 30. Both means the same thing, but the second version is much easier to read. This feature was added in Java 7. And the last one is suffixes for numeric literals. Numeric literals can also include suffixes to specify their type. If we add L or small letter l, it tells the compiler that the literal is of type long. For example, long big equal to 10 like L. If we add F or small letter f, it specifies a float, such as float price equal to 99.9 F. For double, the suffix d or small letter d is optional since double is the default type of floating point numbers. These numeral literals are important for a few reasons. They improve readability, especially when using underscores. They allow us to work with multiple number systems like binary and hexadecimal, which are important in hardware programming and algorithms. They are commonly used in constants, memory addresses, and calculations. Example of numeric literals. So this is the example. Here we can see we created a class named numeric literals demo, and we are assigning like the integer literals as we seen previously. Yeah, we give int decimal equal to 25, in binary, in octal, in hexadecimal, and the floating point literals and underscore using underscore. All these things we have already seen, and this code is used to print the output. This is the decision making loop. Here what happens is it checks that uh, the value of I equal to 1, and then if I is less than or equal to 5, the value of I increases, and if I divided by 2 equal to 0, the system give will print it is even, the value of I is even. Else, if this condition is wrong, it will print I is odd. So let's see the output. For that, we can open the terminal and we have to direct to the correct directory. Now we are on the correct directory. Now we have to compile this code first. For that, we are using the code Java C. The exact name as the class name. We have to give .java also while compiling the code. It compiles successfully. Now we can run this code. This time we don't need this C and this .java. Look, we get the answer, the correct output. We can see here we give in binary equal to 0b11001, but in the output it gives 25. All the values we can see that here, and it is also giving that it is odd or even. So this is happen while running the code. Here all integer literals shows the same decimal values. Look, all integer values. These are all showing the same decimal values. And the floating point, these three, double pi, float price and double scientific, are printed as expected. And the loop print odd or even numbers correctly. Now we can debug this. Here, the debug lets us see the program flow and variable states, unlike run when just print out. Run which just print out, it also shows how the program program is working. It was showing its flow. To conclude, numeric literals represent fixed numbers in Java. They can be written in decimal, binary, octal, or hexadecimal forms. Java supports floating point literals, underscores for readability, and suffixes like L, F, and D. With a simple demo, we saw how literals can be combined with decision making and loops in IntelliJ IDE. I hope I hope this gave you a clear understanding of numeric literals. Thank you.